Got it. Okay. Okay, let's continue. I hope you're motivated. So with the first part, what we have seen is we use music brains, and then we add all the albums, and then we build this network X graph, and then we obtain this JSON that basically codifies the same information. What I just did now in the break, I uploaded this JSON in this JSON viewer. I don't know if you have ever used this. And basically what we are seeing here is like what is in this JSON that we just produced. So basically, yeah, for some reason, my laptop is, I don't know what it's doing. It's just like using a lot of CPU, and I really don't know why. Yeah, I'm sorry for that. I hope it doesn't want to close as many programs as possible. Give me 10 seconds. I hope this helped a bit, but sadly, I think that my Zoom is using a lot of resources today, and I can't understand exactly why. But the thing is that I uploaded the JSON that we just created here, and then we can see that we have this JSON, and then we have nodes and links. And for each of the nodes, we have all the nodes enumerated here. And then for each of the nodes, we have like ID, being John Coltrane, so the name, and then the degree, which is the degree of this node. We have it here because actually NetworkX gives us this information. And then for each of these nodes, we have links, which is another name for edges. And then, for instance, we have link 0, and link 0 is source, is John Coltrane, and the target is André Jolivet. And the weight of this edge is 1. I think that weight is always 1 in this specific network because we are not going to use this information, which obviously, as you know, we could use it as also we mentioned at the beginning of the lecture. So okay, so this is the thing, right? We have nodes and listed all the nodes, and then we have the links, and then we have source and target, which basically connect the nodes that actually are listed here. I'm showing you this for having like in mind what sort of information we need actually to build an interactive network with JavaScript. Okay, we're going to use JavaScript, as I said, but we're going to use specifically observable notebooks. And I'm curious if any of you actually use observable notebooks. If anyone, please let me know in the chat. And if you want also, you can let me know if you ever use or you are familiar with JavaScript. And let me find the chat. Okay. Well, if anyone wants to participate, there's a poll. And let me know if you're familiar, not okay. Okay, that's good. Okay, well, it will be then slightly harder, but it's going to be fine. JavaScript is a lot of fun. It is a bit like Python, but it has specifically, okay, a little bit of JavaScript. That's with Alessia. It has a bit of, it has a lot of similarities, but also it has key differences. And some of the differences also came from that JavaScript is used for running in a browser. And for that reason, actually, it is designed in a different way because there are like specific singularities. We are not going to explore this here, but I want just you to keep it in mind. Oh, I went too far, sorry. Okay, so the thing is that I'm using observable. If you want, you can now go to observablehq.com, and if you have a GitHub account, you can basically log in, but you can also create one with your email address, I think. But I have mine connected with GitHub. And basically, you can go to observablehq.com, and then you can sign up. And then if you want, you can try to follow this real time, or at least play a bit with it while I'm explaining what is all of this about. So I'm sorry, I'm going to go straight for it, but please do it. I mean, just sign up. It's 10 seconds if you do it with GitHub in case you have an account. Okay, but what I'm going to do now is I'm going to create a notebook. I mean, the idea of observable notebooks is that it's somehow like Jupyter notebooks, but for JavaScript. The parallel is actually not correct. It's not completely correct, but it makes some sort of sense. There are differences, and one of the differences, and I think it's important, is that these notebooks have been developed by people that actually are data visualization experts. And for that reason, these notebooks are really, really designed actually to show you the results of data visualization, the results of data analysis and text in a neat way, in a clear way. And I mean, we might agree or not, but I think that Jupyter notebooks actually are not the clearest way in terms of like styling. Sometimes they're like cluttered and you have like the code there and actually it's not super beautiful or clean. But actually observable notebooks can be really, really neat in the result. I really encourage you to use observable notebooks to learn JavaScript. These are really useful languages. It's a lot of fun. And in addition, observable notebooks, I mean, there are plenty of examples out there that are amazing. I included a few examples of, well, the guide of this session is an observable notebook. And basically, in the end of this notebook, and the notebook I showed you, there are a few examples that I like. Maybe more fancy, some others are simpler, but these are examples of observable notebooks that I like. Okay, what I'm going to do now is I'm going to show you a bit of observable notebooks, a quick introduction. The first thing that we're going to do is create an introduction. It has a cell, it has, I don't know, it has the owner. Sadly, at this moment, you can only create public notebooks unless you pay. So free accounts can only create public notebooks. In the past, it was different. 1 year ago, private users also could create private notebooks. Private users, free users could create private notebooks, but sadly, this is not anymore the case. So the first line, and so the first cell, actually, it is used to set the title. So if we say shift enter, basically we have created the title. And now you can see also it is here, it's labeled on top of the browser. So the title of the window is actually the name of the notebook. So if we do Control Enter, then we can create a new cell. One of the nice things, and this is also, I know that you can also create this in Jupyter Lab, is that we can create different types of cells. But here we have many types. We have JavaScript, we have Markdown, we have HTML, and we have other types that I will show you in a second. Most of it will be JavaScript because it is Python. It allows us to make calculations and so on. And for instance, we can make calculations like this one. We can also define variables. And here, I don't want to go too much into detail, but basically JavaScript, you have to, it's a typed language, so you have to specify which sort of variable you're creating. So number, you can say var for a variable, let for a variable also, or const for a constant in JavaScript. But here it's actually not JavaScript. It's an enhanced version of JavaScript, and it's not typed. So you don't have to specify the type of variable. So if you say number 3, number, or basically this enhanced JavaScript can automatically detect that number is that this 3 is a number, so it will automatically say number is integer in this case. Okay, so here we have. Let me remind you something. If you do Shift Enter, basically you will just run the cell. If you do Control Enter, you will run the cell and create a new one, and it will allow you to select what sort of new cell you want to create. It could be Markdown, it could be JavaScript, whatever. But if you type, if you use the shortcut Control Alt Enter, well, at least in Linux and probably in Windows, what you're creating is a new JavaScript cell. Well, in this case, since we haven't added anything, you cannot see that. So, for instance, let's create now the list. 1, 2, 3, 4. Now I created a list, like this is like Python. And now I'm going to use this shortcut, Control Alt Enter. And basically I created like a list, and I just run the cell and I created a new JavaScript cell. Okay, let me define you a function for you. It's very similar to Python here, function xi. I don't want to get confused between Python and JavaScript. And then now, as you see, this is pure JavaScript. So we have to define that this is a variable. The variable double is 2. And basically we can change and say here double x and y. So basically double product will be 2 times x times y. And this is what we're like sending through the arguments. So Control Alt Enter, I'm creating a new JavaScript cell. And now I'm basically running this cell. Double product, I'm running the function. Control Enter in this case. Well, Shift Enter, I would say. And then we have 12. 2 times 3, 6. 6 times 2, 12. Okay. This like the most simplest introduction I could give to you. Like, as I said, this is mostly JavaScript, what is in here. But we can also, as we've seen, we can create different types of cells. Let's explore a bit this idea. Let's create an HTML cell, and let's use a bit of HTML to see what we can do. I don't know if you're familiar with HTML. I won't actually say anything about HTML, but HTML works with different elements. This is a paragraph element, so I'm going to create a paragraph that actually has a background color yellow. So if I run this, I'm a highlighted paragraph that I created for you. Now, I'm going to create now a new cell, and I'm going to create a markdown cell. So Control Enter, Markdown. And basically, I hope you're familiar with Markdown. Markdown, you can have headings, and probably you're all familiar with Markdown, but you can have headings, and you can have italic text, bold text, and actually more things that we have here. And if we run this, we automatically can code this Markdown text. Okay, I'm going to create a new JavaScript cell, and as I said, Control Alt Enter is our shortcut. But this time, I'm not going to use JavaScript. I'm going to do the following thing. I'm going to say I want a text, and this is LaTeX, not text, sorry, but text. Okay, and if I click here now, what I'm doing is the JavaScript cell now is being understood as a LaTeX cell. Okay, and I don't know if all of you are familiar with LaTeX, but LaTeX is actually used for I'm missing this word today, for rendering equations. So if I run this cell basically with Shift Enter, now the browser is able to automatically render LaTeX, and then we have a nicely rendered equation. I mean, LaTeX is extremely complex, and you can do as everything you want in terms of functions. So this is obviously a very simple one, an equation which probably you have never seen before. So you can do this is very simple, but you could do really, really complicated stuff and embed it here. And this is a good moment actually to stop here and show you something that I really like, which is that you can unpin and pin the cells. So here we see the result, we have the rendered cell, and we have the code of the cell. But if I do this now, and I close the cell, you don't see anymore the code. So we only see the result. And why is like that? It is like that because, as I told you, this is something that it was designed by data visualization experts, and they wanted to do something neat, something clean, that you can combine text with data visualization in a very integrated way. Something that you could do also is create a cell and JavaScript cell, and you can combine Markdown with JavaScript, so something like this. Okay, so now this is current time, and then with like this dollar and this Cloud with this bracket, basically I'm creating local time at this very moment. So the current time is the current time here well, now I'm in Catalonia. So okay. Last thing, I'm going to show you very quickly another thing that I love from observable, and I think this is one of the reasons I love using this, and I wanted you to show. I think it's nice to learn it. Is because we can add very simple forms of interaction in 0 seconds. I know that with Python, actually, these things are getting simplified, and now it's also very easy. But I mean, I don't know. We're using a browser; it's super easy to share, and it's enhanced for data visualization. So I think these are all good arguments to use also observable notebooks. So we can add buttons, we can add inputs, basically. We can add radio buttons. Let me show you. And we can add also ranges as simple as with one single line. So let me show you what we're doing here. We have like this button, click me. And every time that we click it, actually the information the click is being recorded in the click variable. We have like these 3 radio buttons. So the value of the radio button is being coded, is being stored in this variable color. And the same thing applies for this range. So for this range, if we move around this value, basically what we see here is this n variable is basically storing this information. So now it's 131. So what should happen is that if we create a new cell in JavaScript and then we run the cell, my computer allowing, we should see 131, but it's not the case. Okay, well, that's fine. Because what happens here is that we are seeing the HTML element of this range, because this actually drops this. So think about it. I mean, if we are using this and we are storing in this variable and we see this, actually what is more reasonable is that n is not the number, but actually is the whole HTML element, this element that we see here. And this is what we see here, actually. So if we want to have this variable to store the value and not to store the HTML element, we should do this. And now we have it. N is 128. And then if I change the value, dynamically, the N is changing and the value is changing. And this is impressive because the thing is that if now this is part of a function, everything is being automatically recalculated. So if I use this, and basically when I'm moving the range, basically the function is also being automatically recalculated. So this is a continuous process, you know, and all the different relationship between the cells are automatically being recalculated when a cell is re-rendered, like in this case. And this is one of the most powerful things, in my opinion, observable, that actually cells are not isolated, but are a network of variables that are interconnected. Last thing, I mean, similarly to Python, we need to import packages, right, in JavaScript. And the way to do this here is using require. So instead of like import pandas as PD, yes, and basically we use require, and Lodash is a package to process to make like to work with data. It's a bit like pandas, but it has nothing to do. But let's say it's like pandas, and basically we store it in this variable. Since it's a low dash, and normally is used like this variable with this values. It would be like this would be like PD in pandas, but in this case it's a low dash. And the second thing, and we're going to use this thing also, is we need D3. Okay, now I'm going to declare D3. And basically, D3 is the core of data visualization in JavaScript. Sadly, I cannot go into a lot of detail with D3, but I want just you to remember that D3 is the library that powers us when we want to make data visualization in JavaScript. D3 is a JavaScript library that basically allows us to fetch data, to process this data, and prepare it to be plotted. It allows us to deal with complex mathematical objects, transformations, and simulations to work with this data. It allows us to manage visual objects and plots. It allows us to also change the statistical parts of this chart that we're building with D3. And then also it allows us to manage the interactivity with the user. So what happens when the user clicks the node? What happens when the user hovers or moves one of the nodes? So all of this, it is thanks to D3, which is this library in JavaScript. The thing is that, I mean, D3 here is like pandas, but it's for dealing with data visualization in the context of JavaScript. You can find more information on D3 basically in the session guide here. I remember you, just remind you here. Here in the lower part, there are a few resources. There are resources about observable. You have like here some tutorials. You have here some D3, learn D3 introduction. Well, there's plenty of stuff. There are many things. Some examples that I selected because I like them, some others because I think it's important to see them, and so on and so forth. And these are actually very cool examples of observable notebooks. This one is very impressive, for instance. And these are other very nice visualization libraries in JavaScript and observable. This is great things also to explore. Let me point now, this is the guide I showed you, and I hope that you know what I mean. These useful functions, just keep them in mind because we're going to use them right now. The idea is to copy paste them, and to copy paste them, you should like open the cell and then basically select it and copy it and then paste it on your own notebook. Okay, so I quickly introduce you to observable. Now it's time to create an interactive network of charcoal trains co-authorships. For that, I'm going to create a new notebook. Sadly, as I said before, it has to be public. You cannot create private nodes anymore. So it will be a blank notebook by default. Okay. And let's give it 1 second. Let's take some time. And let's get down to business. Okay, so John Coltrane's co-authorship network. Okay, first thing first, remember the Control Alt Enter in case you are also like playing with this to create a new JavaScript cell. Okay, the first thing that we need is we need to import packages. We have to require stuff that we need. But before that, let's do something. Let's make this a bit organized. I haven't been very organized in Python. I'm aware of that. I was a bit cognizant with time, but now we have a bit more time. So let's say import libraries, import needed libraries maybe. Okay, so we have this small markdown text, so we have it a bit more organized. And now I'm requiring, first of all, D3, which as you can see, it was the low 94, more than 94 million times. Right now, more than 100 million for sure. Okay, Control Alt Enter, and then I'm requiring also Lodice. We need Lodice to process arrays and dictionaries. It's a very powerful JavaScript library. Don't worry too much about this. I'm going to unpin these ones and hide the code because I just want to be there. I don't want to do anything with them. It just, yeah, imported them and you can see what we imported them, but not else. The second thing that we want to do, this is another way to declare Markdown, is we want to import the data. But before we import the data, we basically need to upload it into our observable notebook. And this is very cool because, I mean, when you're working with Jupyter Lab, obviously you're working your own laptop, but here we're working in the browser. So we need to, in some way, we have to allow observable notebook to use the data. So to do that, and what they proposed is they created this functionality with this file attachment. And then what we do here, we're going to upload this object, this JSON file that I shared with you in the chat. So I'm going to open it. And then basically it's being uploaded, it's being processed. And then if I click here, it's super simple because if I click here, it is actually, now we have it, okay? It's as simple as that. Now we have this function, file attachment, and then it automatically converts it to JSON because it detects that it's a JSON and it gives me this JSON object automatically processed. Okay, I'm going to say, if you start to remember what I said before, let row graph, it's pure JavaScript. But here we have observable JavaScript, which is another sort of JavaScript, and it is not typed. So what I'm going to do here is I'm going to create a block. I think I haven't said this before. A block is a is a block of JavaScript, basically, where we can execute things, and it is defined like this. We have one variable name, and then equal to, and then this is the block. Here there will be some executions, and in the end there will be a return, and it will return some data, and it will return a variable. So the first thing is that I'm going to save this file attachment, this JSON, into this variable, and then basically I'm going to return it to graph. So now, as you can see, we have our graph that it contains the JSON object that I showed you before. It has the nodes, it has the links, and now we have it in our notebook. Okay, the third thing that we want to do is we want now to add some functions. Okay, the functions that I'm going to add here are the ones that I showed you before in the guide, are the ones that were in the lower part of the guide. They can be basically copied here. Let me show. Yeah. So there is a drag function. This one basically it is it will tell our notebook, our network, how should behave when we're dragging the nodes. The second one is a color one, which actually will help us to color the nodes according to their degree. And the third one basically is this one is very massive actually. This should be a package that is not working because it's a bit old, but it works very well, so it's fine. And this one basically is the JLooping function, which we will use it to detect loop communities automatically in the browser. Okay, actually now we can also close these functions because we don't want them to, we just want them to be accessible for all the notebook, and that actually why we declare it here, but we will just leave them here. So at this moment we have three functions that we need to process the information. We have the data that is ready with these relationships, and well, basically now we are ready to start plotting. I'm having some serious upload now. Okay. Okay, so now it's time to almost start, but we need to declare three constants. The first one is the minimum degree that we want to allow this network, like this. So minimum degree here is coding the minimum degree of the nodes that we allow to appear in this network. So if we say 1, all nodes will appear. If we say 2, only those nodes with degree 2 or higher will appear in the network. That's a 1. The second one is the node size. So what is the maximum, the biggest node? What is the size of this node? And then collide strength, we will see it in a second. But actually this tell us how apart the nodes will be in the network. I will explain this in a minute. It's just, these are like some variables that we need. Okay, and now we can basically create the network. To create the network, we need to create another observable block, and we created like this. Remember that observable JavaScript is not typed, so we just do this, and now we have a block where normal JavaScript can go inside, and then this one is typed, so we have to say const radius range is 5. This is like the range between the biggest the smaller node and the biggest node. What is the range of the size that they will have? And then the second thing that we declare is the height of the network. It will be 600 pixels. Okay. Now, as I told you before, we can use D3 to declare, and we can work with like visual objects. We can like work with the statics, but we can also use it to create simulations. And in this case, we will use D3 to create a simulation of how the nodes and the links should behave. Basically, and this is also happens in Gephi or also in Networks, we will be using a simulation of springs. So basically, what we will do is like the nodes, we will simulate that they are connected with the springs. So they automatically, we will like hit the system, and then automatically will cool down in a way that in the end it will become freeze in a position that naturally the system unfolds as if all the system were like connected by springs. In order to do this, what we need to do is we should start with this line, which says, okay, let me create a simulation, which is a D3 force simulation. And we are like adding all the nodes to this force simulation. And the first thing that we have to do is we add a force link. And what is a force link? Force link, you say, okay, so this is actually, in my opinion, quite simple. Well, the syntax, let's say that is simple of this language. So basically, we create a force simulation, and then we add a force. Dot force, and I'm saying this force will be named link, and it will be a force link. And what is a force link? Force link basically applies between the source and the target of each of the edges simulation of if they were connected with the spring. So this is actually the spring simulation. Basically, yeah, the link force pushes links together or apart depending on the link distance. Okay, I mean the idea here is that we're adding this force that is a spring simulation. That's all. But it's not enough. I'm going to add more forces to this simulation. The second force I will add is the force many body. Okay. The force many body is basically a force that applies simultaneously to all nodes. And basically, it can be used to simulate gravity, attraction to all nodes, if the strength parameter is positive, or electrostatic charge, repulsion, if the strength is negative. In this case, it's negative. So what we are doing here is like, we're forcing all the nodes to actually be separated simultaneously. So in other like more simple terms, we're giving some air to this network by doing this. We get imposing this force that separates all the nodes among them, not only from the center, but among them, because this force is applied to all nodes in the network. The third force that we're applying is a force center. Okay, we will call it center, and actually it will be a D3 for center. And this one is very simple. This one is a force that takes the node and it moves it to the position that we specified. In this case, if we take width and we divide it by 2, and then we take height and we divide it by 2, we have the center of the visualization. And the last one I want to use is the force collide. Okay. Basically, force collide, what it does is for each of the nodes, if we don't use force collide, basically each of the nodes would be understood in the simulation as points. So the simulation wouldn't see actually that they have some space because they have some degree and the nodes take some space, right? So by using the force collide, what we are doing is that we're saying, okay, these nodes actually have some radius, they take some space. And by doing this, the simulation knows that, and then we avoid overlapping because the simulation will never allow them to go one on top of the other by adding this force collide. So basically, we said the force link simulates a spring simulation. The force many body give airs to give separation to all, give like distance to all the nodes. The force centers move the whole node to the center, and the force collide is avoiding overlapping. So in this way, we will never have one node in top of the other. And the beautiful thing of this is that we have this dynamic effect. And I think this is one of the key beautiful things of like interactive visualization or dynamic visualization, as this is an automatic thing, right? I mean, it's alive, like the network is alive. If we filter, if we click, if we move, all this spring model that we created, it will automatically hit up, it will move again, and then it will come down to give us an optimal visualization for each of the settings that we choose. Okay. Now we have our simulation declared. Now I'm going to create an SVG element. An SVG is, for those that are not familiar with this, is a scalable vector graphics element. It's basically a canvas where we can add vectorial elements. So the thing is that we're now in a browser. I'm going to add this SVG element. And in this SVG element, and you should imagine as a canvas where we can paint instead of painting. What we will do is we will add vectorial elements, which are nodes, are edges, are labels afterwards. And not only that, SVG also can be automatically re-rendered in milliseconds, basically. So SVG is also very powerful for dynamic and animation and interactivity. Okay, so now we have our canvas. We have a canvas which is called an SVG element. And then what I'm adding is a G. And this SVG, I'm adding a group. And this group, actually, I'm adding all the lines. What is a line? A line is an edge. So I'm adding this line object, which will represent the edges in the network. And I'm saying that this line should have a gray color. It should have a 60% of opacity. And the width of these lines should be 1. So the width of these edges should be 1 pixel. And that's all. So I created this G element, which is a group. This is like, actually, this probably might not be needed to work properly. We need it, but in general, maybe we won't need it. But inside this group, what we do is I append all these lines that basically will represent in this SVG, in this vectorial space, the edges. Then this is slightly, I'm not going to give a lot of details on this, but basically this is a function that allows us to say, okay, in the degree of the nodes, we want to make them, we have some degree of the nodes, and then we want this to be represented according to, proportionally to the size of the nodes. So what we do here is that we create a function that goes from one range, which is the range of the degrees, to the range that the SVG, our canvas, understands as the node of the node size. So it's a function that transforms from one range to the others, one range being the one that actually will appear in the screen, and the one is the degree of the nodes. Don't worry too much if it's not clear. It's just we need this mathematical function to represent the degree of the nodes as proportional to their size. Okay, we have edges, but we have not nodes. So I'm going to add the nodes now. And the procedure is always the same. We append in the SVG, we append a group. In this group, we basically add the cycles, we will do this join. And then we say we want them the stroke, so the surrounding, let's say the perimeter should be wide. The stroke width should be 1.5 pixels. And we add the data, which is the graph nodes, obviously. And then we say that the radius should be proportional to the degree according to the relationship established by this function that I just told. Okay. But in addition to that, I don't only want to have like a degree that is proportional to the radius that is proportional to the degree, but I want also them to have some color. As the first step, I'm going to say that add an attribute fill and then say that it's orange. So just at the very much at the beginning, we will have like this network that it would be orange. But in a moment, this will have another color. And then the second thing that I'm going to do is I'm going to add this drag function here, which if you remember, we declared it here in the end. You see it? Is it here, drag function? And basically what this is doing is by calling this function drag, what this allows us is that when you move a node, everything is recalculated, and it's recalculated according to the simulation that I'm passing to this drag function. So this allows us to have a network that is dynamic, that when you move the nodes, the simulation runs again. If we wouldn't do this, you would move a node, but the network wouldn't do anything. But we want it to be always as dynamic and especially alive as possible. Okay. Actually, we're getting close to having a first network. I think we need this. Yes. Okay. Now we need this. Basically, this is saying that every time that the simulation that I told you, this is spring simulation with these forces, is running every 30 milliseconds, a few milliseconds, I don't remember. And every time that this happens, that the simulation ticks. So every time that the simulation is recalculated, and this happens every few milliseconds, we want that the position of the links and the position of the nodes is established according to the simulation values. So for instance, if we have like the simulation of nodes, and then the springs are getting closer, we want that every time that the simulation is ticking, so it's recalculating, we want to update it automatically so the nodes and the strings, the nodes and the edges are updated. The position is updated according to the new values of the simulation. And we do this through this function here. We need one additional layer, which is this one. This one is says that every time that we do Shift Enter and we run again the cell, we stop the simulation. In this way, we avoid having 10,000 simulations running continuously. And basically, at the end, we return the SVG. But we return the HTML element of this SVG. Otherwise, the browser wouldn't be allowed to run it. So now if I do Shift Enter, we have a network. Actually, this network is the same that this network that we have seen before. The only thing is that now actually it's interactive, so we can move it around. And as I told you, every time that we drag it, and that's why we added the call drag simulation function, we basically have all the things, all the springs are behind. You know, like you have to imagine that the edges are springs, and the springs are elongated, and then they come to their natural position. And the thing happens with for any node that we move around. We can also like now, oh, the position, interesting. I guess that we have to update the data. Yes, if we update the data, then it updates. Okay. Okay, that is one first step, and we have a few minutes. So why don't we add a few more things? The first thing that we are going to add is we are going to create some labels. And personally, I really like having labels. The problem is that sometimes they make a bit more difficult to read the network, but they are nice. So basically, what we're going to do is, give me 1 second. We are going to add here exactly the same thing as we have seen so far. We have this SVG. We append a new group. We added a few text. We say that this text should be, this is gray, by the way, this is a HTML color coding. This is gray. We select them all. We load the data, and then we say the text should be the ID of these edges, of this node, sorry. Here I'm saying that you cannot interact with the labels. And here I'm adding like I'm moving, you know, I'm shifting the label like 4 pixels to the right. So it gives a bit of distance between the node and the label. And with this alignment baseline, what I'm doing is I'm aligning the node and the label. I'm just showing you like to make it a bit more clear what all of this is about. There's one thing that is missing, which is this one. We need to add the objects to the simulation, otherwise they will not appear. Yes. And here we have them. Sadly, in my opinion, they are a bit. It looks a bit cluttered. It looks a bit many. Going to give a bit slightly more height to this network. And maybe we can change the collide to give a more space in the network, maybe 30. Doesn't change enormously, but yeah, it's slightly too cluttered. But here we have it. At least now we can identify who is each of these people in the network, which is nice. Yeah, for instance, here is we could set here like different angles. I mean, you can do plenty of things. I mean, maybe this is if any of you get like very into this, then you can try to find a way where you can prettily see all the labels in the network. Maybe by using also another collide force, you know, that avoids overlapping. This could be an option. I don't know. Just play with it if you want and you have time. The third thing that I would like to do is let's play with the colors. This is fun. Okay, so now all the colors in the only color that we have is orange. But the first thing I want to do is show you how we can color them by the degree. This is very simple. Instead of saying orange, as I wrote here, I'm going to change it by the color function. And remember the color function, I copied here, I give you this function. And basically what we have here is like darker color. It means that the degree is higher, lower color, and well, lighter color. Lighter color means that the degree is lower. I mean, it's a very, we have like a very high degree node and the rest have like a very flat distribution of degrees. The rest that have almost all of them the same color. That's why we can't actually see much difference. But maybe what we could do is actually code this by Louvain. So instead of like coding by degree, what we can do is detect communities. And basically, a community is a set of nodes that actually tend to be like more interconnected between them. So they tend to collaborate more. And we can see this visually by using Louvain, which is this function that we have here below. And we give all the nodes and the links. And then this function will give us those communities within this network. And I'm going to do this basically, to do this, it's not super complicated, but we have to add some code here. We have to process the data. So what I'm going to do here is like, I'm going to list the nodes in the network. I'm going to list the degree of those nodes in the network. And then I'm going also to list the edges on the network. And then instead of returning this row graph or this object, what I'm going to do is I'm going to return a dictionary. And this dictionary basically will have three things. One are the nodes with the nodes, basically, the links with the edges, and then the communities with JLouvain. And I send this function the list of degree nodes. I'm sending the degree of the edges. And basically this function afterwards will give us the community detection. Don't worry too much. This is like the overall idea. And then the other thing that we have to do now is, it's basically actually like, it doesn't require a lot of code actually in this case to add this functionality. So basically now instead of like using this color function, what we say is like fill now in this case is graph.communities. So this is the data. Communities is the JLouvain. And then I say to this, okay, so the thing is that these communities will give us the JLouvain community detection. And this will be a dictionary saying node whatever is in this community. And this community will be a number. So if I send this dictionary that this is giving, and I send the ID of the node, it will give me the number of the community. And given that this is a number, I can just say send it, which is an array of colors. And then as this is a number, it will give me the color. It will give me a color according to the position, a number of. Okay, so again, we have the ID of the node. This will give me a number, and this number is the number of the community. And then I can use this number to code it to an array of colors. And this is the 3D scheme pair. Okay, and play with it. I mean, this is not super simple to explain, but please play with it and then you will see. I missed something this time. Yes, I have no clue what could be wrong. That's strange.
Do you have any type of message?
Yeah, maybe yes. Okay, maybe we will have to skip it because we have too little time. I mean, this should work. I just checked it yesterday, to be honest. Well, apologies. We cannot choose this now as a picture because this is important.
Is this working now?
No.
No, isn't working either.
I- maybe.
So now nothing works.
No. It's actually very strange because I mean we did this a few times already. That's super strange. First that it does not even work if I come back.
Even the original doesn't work.
Yeah, exactly. Um in this case, I will show you the final result, which were very, very close. Which is this one.
That is a trick.
Yeah. That is the quick way. But yeah, basically here we have it.
This mouse in, mouse out.
Yeah, this is additionally, I'm going to tell you also, it's a pity, but it's almost the same. The only thing is that we just added this thing. Well, it doesn't matter. Okay, well, so well, actually, if we run if it will be working, which I really don't understand why it doesn't work. This is exactly the same as here. There's nothing different. I'm going to copy this. Maybe it's a small type or something. No, not just a problem. It's actually surprising. Okay. It does not even work, this one.
No, I see.
Oh, wow. So observable is tricking me. Mystery. Wow. Aha. I see what maybe is happening. For some reason, the file attachment is not working now. It's here.
So you lost the file.
Yes, sorry, I'm actually, but not exactly. Well, you see that you see here the problem. For some reason, this is not working now. which is unbelievable. But I'm sorry, guys, it's 8 o'clock, so we have to stop. But basically, the idea is that with JDomain, if that would work, we would see exactly this, which is like now we can see like with one color this network, then we can see with red another community, in dark blue another community, in green another community, and so on and so forth. So this is the people that tend to have like closer collaborations. And in this case specifically, it obviously very correlated with the albums that they play together, obviously. But yeah, I mean, if anyone in the class is an expert in jazz, might tell us like maybe this is pretty telling about John Coltrane's career, hopefully. And there was another thing, an additional thing I wanted to show you, and I know that it's 8 o'clock, it will take us just 1 minute, is that we can also show and hide nodes for the first neighbor nodes. So for instance, here by adding this mouse over and this mouse out. So this is telling us when you go to a node and then you hover, so you go on top of the node with the mouse. This is basically filtering and then reducing the opacity of all these nodes that are not directly connected. And when we leave the mouse from the node, this is actually in restoring the opacity of the whole network. So you can see this, like if I go here and I go to this node, you can see that only those nodes that actually are directly connected to Elmo Hope basically now are shown, and the rest are basically hide. And the last thing that we can conclude is that, as I showed you before, observable also allows us to add these nice ranges. I have shown you this before, so we can also use them here. And in this way, we are adding a nice interactivity to our network. So for instance, if we modify the collide force, you see the nodes now are closer because the radius that allows the avoids overlapping, basically, it's getting reduced. Or if we increase it now, there's a bigger overlapping radius that actually separating the different nodes. Another one that is nice is this one. Okay, so with this range, with this slice, actually, what we can do is we can filter the network according to a specific minimum degree of the nodes that should have to appear in the network. So if we say 2 or 3, only nodes with a degree of 3 or higher are actually now appearing in the network. If I say 10, only those that actually have like 10 edges, like leaving, actually appear in the network. And this is like the full network. And there's another one, which is the maximum node size. This we can use this to change basically the distribution of the size of the nodes in the network. And that's all. I hope you like it. That is the idea. I'm sorry that something went wrong. To be honest, I have no clue what this time. Okay. Thank you for. I think most of us know LaTeX. I was not sure.
So this one is so the link that you're putting here is the one that works.
Yes, this is the one that works, because the other one is it's published, but yeah, forget about the other one. It was only for this class. This is the one I would like to share with you, also because all the code here is commented. So if you want to review it, it has tons of comments actually and explains what each of the lines are doing. We are 3 minutes over, but if you have any questions, I'm really happy to give an answer to them. And yeah, I don't know if you enjoy it, if it was a bit.
Or perhaps you have any question, you can send them to me. And then I can forward it to Arnau.
So yes, I will be happy to.
So now it's time you can play with your networks and see how it works.
I mean, at this point, the easiest thing to do is using the notebook that the other one that we built, and basically changing the Music Brains ID and then playing with another musicians and cloning this one and then uploading a new JSON and then playing with different musicians. And then please, I invite you to play with this, change any parameter, like explore, break the code, and then try to understand how this works and how it can be improved. And also see here now that actually the labels look very good, very nice. Also because we increased the collide force.
Yeah, and you can change the font.
Of course.
And the sizes, everything. You can.
Oh, nice. Okay. Thank you, JD, for your nice comment. It's good to hear this, even if we had a big issue with the network.
Okay.
Excellent.
So here we are. So Arnau, muchas gracias.
No worries.
I, bueno, seguim en contacte. I
Excellent.
si volen fer alguna pregunta, doncs ja te la reenviaré jo.
Absolutely.
Gràcies
Yeah.
per...
Any questions? Perfecte.
Vale, molt bé.
Doncs molt bé.
Doncs que acabi d'anar bé l'estada per casa
Exacte.
i si vens,
Molt bé.
si vens algun dia per Barcelona, doncs ens veiem.
A veure el juliol, a veure com va.
Vale. Molt bé. Vinga, sí.
Molt bé. Thank you, everyone. Have a nice evening.
Adéu.
Bye-bye.
So you like the visualization session? It was. I don't know what happened at the end, sorry, but I think you can manage. So because the last part of looking at precisely at the different colors for the communities is very nice. It was very useful because you can really identify how they organize. We have the data. Yeah. That's it. Sure. It looks very simple.
Yeah, I'm sure that's I mean, I think we can get our graphs into the JSON format and just.
Okay, that's it. Yeah. You can have something. Yeah.
I'd love to see them.
Okay, that's the first time.
Dynamics, I'm trying to use dynamics and and I want to find so I've modeled my graph. Yes, simple, exactly. So and then they're the only two states you have to go back and forth between each. I want to have a probability distribution. So let's say every week, I'll have all the data and a web page in a converted session. It wasn't in a converted session. So every week it has it's like the search base will always be infected.
Yeah. So this is about you referring to types of
it's converted.
Yeah, but the converted and not converted, they were connected. You get different.
So yeah, I had all the sessions that were converted, all the sessions that weren't converted separate. Yeah. If I put it all into one graph,
yes,
there will still be nodes that there's kind of nodes on the fringes,
yeah,
that will be non-converted.
Okay.
And and then there'll be some nodes that it will be converted because basically this is the best way I thought dynamics might work is that there'll be nodes that are non-converted. So
what is the meaning of converted and not converted?
Someone bought something. Someone viewed that page, and in that session they bought something.
They bought something. Okay.
Yeah. It doesn't have to be that particular product, but it could be any page. So then you have the search page. Every week, someone will have used the search page and bought something. So basically that'll be infected every week. Infected. And then you have some smaller products that are less popular on the fringes. So you have some more the carts, and you have these will be less popular out here, and there'll be some tiny ones. These are infected, susceptible, infected. And they're kind of connected. I was thinking of doing these are probably always going to be changing from one week to the other. They're less popular. They're bought less frequently. The people look at these and buy them. They're less frequent.
What is the meaning of susceptible?
They were during that week. They were part of a session that had a conversion.
They become part. Okay, they become part of the conversion.
Yeah. So I was thinking of modeling as. But my question is, this is not important. This is the detail. My question is, how do I'm trying to define a probability.
Yeah, you can define
that they move it back and forth, and I can obviously use.
No, but actually, so it was the idea on this modelization. The idea is that how you become susceptible. So once you're susceptible, you are infected. So how you go this way. So going this way is just to have some probability. So theta is a probability. How much you are infected? I want to learn beta. No, then you can give some value, some empirical value. But then here you have some lambda that will get affected. But then it's kind of say is that which is the problem. So you do it in this way. For instance, you have one node, so node I, which is susceptible, and then which is the probability of being. And then you define this probability, and then this probability, for instance, means. So which is the number of this is the sum over, for instance, which is call it M I J of sum J, and
That's the adjacency matrix.
this is a kind of adjacency matrix, but this can be 1 if you are affected, it can be 0 if you are resistant. Then you are summing over the people that are affected, and then
That's the neighbors, yeah.
So that this probability is proportional to the number of affected.
Yeah, okay. It's not, yeah, this is the degree, okay.
Yeah.
I'm just saying,
Multiplied by number.
it's not really a probability because
No, it's a probability.
it's more like a score, no?
Yeah, but let's say in this disease spreading models, it's a probability.
Okay.
So and then when people look at networks and so you look around, and then according to the number of neighbors that you have affected,
Yeah.
then this is the probability for them.
So like it's all like in my case, it's never going to be interesting because basically the search is like always included in a converted session. So that
Yeah, that's the reason for which is the meaning of here of infected or converted or non-converted. So then what you're saying is that in this case you kept the probabilities going back and forward, and they are probably they are independent. So in this case, probability of getting susceptible, of getting infected on what will be infected. Doesn't depend on the state of your neighbor.
I think it's a weighted. I think it's a weighted incoming edge. Yeah, weighted incoming edge. Only in degrees is what I think. Yeah. Okay, yeah, no, it makes sense.
Yeah.
That's what I was thinking. I was just like,
Because when you have real problems and decision of so it's not only. Yeah, because what does it mean? So I can get infected if one of my neighbors is infected, but it's one of the problems of COVID. So because it was depending on how long were you in contact. So that's it. Because then, so it was known that if you were less than, I think it was less than 10 minutes, not so close, then it was very difficult to infect. But if the time was more than 10 minutes, and then it was longer, and then I don't know how many times a day and things like this.
Yeah.
So then, because this is exposure. So it's not only how that you, so here it comes the weight. The weight has to do with the time that you are in contact with this person.
yeah, no, I understand.
Perfect.
Like I figured that out for the dynamics. That's what I'm going to send. I'm going to finish that today, tomorrow. I'll send that to you. I'm not sure about a multi-graph.
Yeah, but then
multi-graph features.
But if it's again, so you can have a graph, and then you can decide which is the type of dynamics that you can have there. So in this case, it's well, I would see very clear. So which is the type
I
of.
mean, I can take my two graphs and make like they're directly.
Yeah, you can overlap them, and you can make you can collapse them.
The analysis.
But you don't need to grasp the analysis.